So today we're going to talk about how to use the area model for integer multiplication. So you already did modeling by grouping, but now we're going to be using an area model. So the first thing is you have to remember that when you're multiplying two numbers or multiplying any amount of numbers, the number you get is called a product. So the product of any two integers can be shown as a rectangle. That's what we're basing this whole idea on, is that anytime you're dealing with a product, which means you're multiplying, you can represent that product by making a rectangle. So one factor, one of the numbers you're multiplying by, is the length, and the other factor is the width. So this product, 3 times 2, can be modeled as a rectangle with a length of 3 and a width of 2. 3 is one of the factors, 2 is the other factor. So 3 is the length, 2 is the width. So we can model that, and we still can use algebra tiles for that. Here we've made a rectangle, right? We can just put them together. Now we have a length of 1, 2, 3, and a width of 2. And the rectangle, the number of tiles in the rectangle, is the product. We have 1, 2, 3, 4, 5, 6. So 3 times 2 is 6. So you would draw that rectangle out on your paper. Length of 3, width of 2, 6 tiles altogether, right? But the question is, what happens when we're multiplying by a negative number? Okay, because these were both positive, it's easy to represent. So what we do to represent negative numbers is that we use a grid with quadrants. Because there's 4 different combinations. There's 4 different combinations of what you can have happen. You can have a positive times a positive, and as we generalized with yesterday's work, a positive times a positive is going to give you a positive. You could end up having a positive times a negative, and as we generalized yesterday, we see that that's going to be negative. You could have a negative times a negative, and that's going to be positive, or you can have a negative times a positive, and that's going to be negative. So there's 4 different kinds of combinations that can happen with multiplying. So we need 4 different quadrants. So first off, I need you to know that these right here are called the factor tracks. So this is a factor track. We're going to label that. And this right here is a factor track. So to use this mat, we need to be able to talk about its parts. That's part of being able to talk about it. So the vocabulary, factor track, factor track. And then in here, this is the area mat. This is an area mat. This is an area mat. This is an area mat. Okay. So to use the area mat, first, you model the factors on the factor track. You build one factor horizontally as the length, and then the other factor vertically as the width. So once you put the tiles down, the factors in the factor track, then you build the rectangle in the area mat. You count the tiles on the area mat, and you have to pay attention to the sign. Don't forget to pay attention to the sign, that's important. And remember, the factors are not part of your own answer. Only the rectangle represents the product, okay? So now we're going to apply these steps, okay? So that might not make as much sense until we apply them. So here I have a problem. Let's say we're going to do 4 times -5, okay? So if I'm going to do 4 times -5, here I have a quadrant mat. That's probably a little big. Let's see. Can't really see, but let's find what section I'm going to use. 4 times -5. 4 times -5, I'm going to build my +4s horizontally, and then I'm going to build my -5s vertically. So that puts me down here in this quadrant. So I'm going to be using this quadrant. So I want to go 4 tiles. So I'm putting, the first factor is 4, and I'm putting it along the positive horizontally. My next factor is -5, so I need to build that as my width, and I'm doing it in the negative, here on the negative factor track, vertically. Okay, so these are my factors. They're not part of the product. They're just there to help me get started. And now I can see I need to fill in a rectangle right here. And I see that this mat's telling me I better make that a negative rectangle. So with negative tiles, I'm going to start filling in the rectangle. So I need to fill in all along here. So this needs a row of 4. This needs a row of 4. This needs a row of 4. So remember, we're just following our rules. We modeled the factors on the factor track. We built one factor horizontally. We built one vertically. Now we're building the rectangle itself. And the rectangle is on the area mat. So now we have a model of the rectangle. And it says count the tiles on the area mat. And pay attention to the sign. Remember, the factors are not part of your answer, so you don't want to be counting these. In fact, you can take them off once you've finished modeling, once you've used them to model if you want. So now you can see we still have a rectangle of length 4 and of width -5. And so we can count. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. -20. So 4 times -5 equals -20. Now what if I wanted to model the problem -2 times -4? So again, I have to figure out which part of the quadrants I need. I'm going to be building my length in the negative direction, and I'm going to be building my width in the negative direction. So I need to be working in this quadrant, right? So I need to put, again, model the factors on the factor track, build one factor horizontally, -2 horizontally. That's my length. Build the other factor vertically, -4. That's my width. And now I'm supposed to build the rectangle in this space right here. But pay attention to the sign. It's positive, right? If I'm going to be building into that space, I need positive. So building the rectangle. And now I'm supposed to count the tiles on the area mat. And pay attention to the sign, it's positive. And remember, the factors are not part. I'm only counting on the area mat. 1, 2, 3, 4, 5, 6, 7, 8. Positive 8. And if you want to, you can take away the factors once you've modeled the rectangle, right? So positive 8. Negative 2 times negative 4 is positive 8. So that is how to use area to model multiplication.